we are back. We are back with our newly launched Lunch and Learn series. The idea is that we are revamping at such point in time is because the industry for industrial manufacturing has evolved quite a lot. And the way we are delivering solutions, the way we have been engaging with the clients, they have evolved quite a lot. So we are thinking, why not share tidbits of what our learnings are, of how we are actually implementing solutions with our clients, and share this knowledge with the world. So today's topic that we'll be discussing is around AI agents, how they are playing a role in manufacturing. Joining me today to discuss this is Vivek Singh, our Chief Data Scientist and AI Officer. He is a graduate from IIT Kanpur, and he has been living this day in and day out. He engages with clients while architecting these solutions, while implementing these solutions on the shop floor. He engages with everyone from the shop floor to the higher management. So he has quite a lot of knowledge. Basically, he can share a lot of insights with us of delivering this. Hi, Vivek. So,
Hey, Siddharth. So I guess you forgot to mention about yourself. So let me do the honors. So along with me, I have Siddharth Jha. He's the head of product. He graduated from IT Bombay and has been working in this industrial AI segment for a while. Understanding all different problem statement, not just of the CEO, CXOs, but of the entire mid management as well as till the operators, and then converting that into product. So yeah.
yeah, thanks a lot for the lovely introduction, Vivek. So, let me try to first set a context of what we are trying to discuss. We will be covering things around why the hype is around AI agents today. What is actually an AI agent? What are the certain practical use cases or applications we have delivered for our customers using this? And basically, then along with AI agents, when we see that it is, getting so deeply integrated into the shop floor systems, is a need for responsible AI as well. And then where we see the future outlook of this going. I hope that is a good context, Vivek. So
yeah, let's make this not a sales pitch but an informative session so that everyone can grab their lunch and parallelly learn with us.
definitely. Okay, so let's get right into it. Now with AI agents, we will be like, I guess for the listeners, everyone in the industry is talking about AI agents. There has been the advent of OpenAI, there has been the advent of Claude. A lot of modules are coming in and day out. Even plant teams are talking about using AI agents in their daily practices. So why not let's start with just discussing where has this hype come from? What has basically changed in the industry, which is causing everyone to talk about it?
Sure. So AI has been a buzzword for the entire last decade and the current decade as well. So what has changed is that one thing is the journey of the data has reached a destination, which is like we have been collecting data, but they were all in different silos. So specifically talking about, let's say, industrial manufacturing segment, we had data like in DCS systems, which was for machines. We had data for all these manuals, maybe in PDFs. We had different Excel sheets creating everyday reports. So all of these data we have lab data. We had other different kind of sources of videos or images. So everything was scattered. What has happened is that with advent of cloud usage of like cloud services, as well as integrating everything together at a single place, we are now able to create a single source of truth. So like this is all unglamorous work, but then this is the most important thing so that we can contextualize the entire view of operations, whatever
Even
is
in
happening.
my experience, I've seen like when I go to plants, right? So they have all these different systems at different levels. You have your PLCs, you have your DCSs, you have your HMIs, you have your LIMS systems, recipe management system. And all of these are very standalone components that they are built right now.
Yes.
They do not talk with each other. If anyone, let's say, had to make a correlation about their production and energy data, right, they would not be able to do it since those two systems are not talking.
But now these are all connected to cloud. So now we have everything like central. So like we have been talking that data is the new oil, right? That oil was scattered all around the globe, some in Venezuela, some in Middle East, some in like Bombay High. But now we created the entire let's say supply chain so that we can first extract this, get it cleaned, and then like ship it to the petrol pump so that it can be used by the vehicles and other applications, right?
And even the industry has probably matured around this. Like we have these now Purdue models, ISO 95 frameworks, which tell us about how to create those unified namespaces around the data itself.
Yeah. The other thing I believe that has changed is that the technology has crossed the line. By that, what I mean is that these new LLM models that have come up, even their reasoning capability has increased a lot. Like they have grown bigger massively. If you remember, like 3 years back when we had OpenAI GPT-3 version, like during that time, all the models had around like 1 billion, 3 billion, maybe 7 billion parameters, right? Currently, if you see the latest models like Fable or even OpenAI's latest model, all of them have 6 trillion models. So it has grown like quite a fold. So the number of parameters has increased. With that, the reasoning capability has increased, and we have also trained them on cleaner data sets, even synthetic data sets that were created by these same models, but those were structured. So this has helped to increase the reasoning capability. And the third thing is that now with the entire LLM ops in place, like the entire plumbing has matured. Like now we can have these different PDFs can be read, and we can connect the databases, analyze all of these data, and through tools, right? So these LLM models got superpowers called tools where they can now take actions, right? So this is what has.
I also remember like back in 2022, right, when you started integrating with LLMs, even incorporating it into our products. So the reasoning capabilities were quite primitive at that point in time. Even doing basic tasks was like you had to do quite a lot of prompt engineering, right? And additionally now, like with the Claude, what they have introduced as a concept, this MCPs. So the supercharging of tools has like evolved this quite a lot.
Yeah, so now they have a menu card of all the actions that it can take. So within this menu card, it can now access like a function which it can call. It has like an API that it can call. Earlier, we only used to get suggestions, but now they have these powers where they can now take actions.
Right.
Yeah.
So I hope this gives a good idea to our listeners also on like what the hype is around AI agents. Another thing maybe is that even plant teams, right, they have started using LLMs quite a lot in their daily life. And this has maybe made them think that why not start using them on their shop floor? Why not start using them in their existing plant production systems?
So they have gained trust of deploying AI models actually in production, not just POCs. And they fear that now if they don't ride this AI bus, like they will lose behind the competitors. So everyone has one or the other project going on which has agentic AI in background. Most of the agentic AI enterprise software will have agentic AI piece. So all the softwares will have agentic AI piece by 2028. So 33% of them will be.
Definitely, we see this trend moving. So now that we have talked about the hype, quite a lot of times that what I have observed is whenever I go to meet clients and they are engaging with a lot of potential partners on how to implement these kind of solutions, what I see is that mostly it is traditional AI models or traditional scripts which are FS logics being repackaged as AI for them.
Yeah.
Like I think this was your observation also, right?
Yeah.
And then it becomes difficult for us as solution partners to basically explain to them that what they have been doing is quite a lot, like very different than what actually is generative AI. We have to explain to them the concepts. And then they'll ask questions, ki how is the differentiation happening? So maybe I guess the next question we should tackle here is like, what is the clear-cut definition of an AI agent?
So to understand what AI agent is, we need to first understand what are traditional machine learning models or copilots that already existed in the market, right? So traditional machine learning models were specifically built on one data set with a specific objective on specific parameters. So the output was clear-cut defined that, okay, it was built to predict a quality parameter to predict, let's say, if there is going to be a fault in the machine, or to predict simply if someone is wearing, let's say, helmet or PPE kit or not, right, in the shop floor. So the objective was very much defined.
A clear-cut defined set of basically parameter space in which that model has to work.
It
There
worked.
is no variability.
It
Right.
worked, but it worked for that specific problem statement, and it gave out the results as well. But someone still had to take actions. Now, one step ahead was where we also had reasoning capabilities by these LLM models, or even complex if-elses, where we created different co-pilots. So these co-pilots were analyzing multiple data sets together so that they can come up with issues that are there in the shop floor, and also recommend as to what are the solutions for those issues, right? So again, there was a human in the loop who was actually taking actions, but then there was a reasoning capability over like static work that these traditional machine learning models had, right?
I think we have delivered such kind of things in quite a few clients. We have these RC engines being built for cements or even for boilers.
Yeah.
Right. And what then normally these AI copilots look like is they have these interfaces in the CCR control rooms themselves beside the operator itself. And then they have their own DCS control screens, and they look at these R advisory copilot recommendations and then take actions.
So it was learning from the engineer's actions. So best engineer, whoever is there in the plant, it was learning from these actions, and then it was democratizing that information across all the shifts or across all the engineers, right? So this is what it did, the
The
co-pilot.
problem we solved here was basically that we did not have to now be restricted onto the experience of the person who is actually operating that ship. Now we
Yes, there is
standardize
a-
that method.
Yeah, there is an advisory co-pilot that is helping or aiding these operators to take actions better, right? But again, they have to take actions, so it is still not autonomous. Now, what agents did was that they, as I told you, had superpowers called tools, or MCPs, as other companies productize. So with this, these AI agents can use all these predictions from these traditional ML models. They can take all the suggestions that they got from these co-pilots, as well as then actually take actions on the shop floor, which means that they are exposed to this set of actionable tools where they can go and write actions on the DCS. They can create a ticket. They can create, let's say, an order for the procurement of any specific item. So all of this can be now done using AI agents.
So why not we maybe for our listeners give a bit more relatable, more simpler example, right? So maybe we have gone too deep into the technical stuff.
Sure. So let me simply put it out. Let's say you are driving a car, right? So you are inside a car. So like predict or traditional ML model is like, let's say, the tire pressure monitoring system that we have, right? The agenda is to just sense if there is any dip in the pressure, and then predict, okay, there is going to be a flat tire, so you take actions now, right? So that is like a traditional machine learning model.
Okay.
Now with connected cars, we also have navigation system inside these cars. So let's say you want to go from, let's say, here to your home. So you can just put in your destination, and it will give you different options.
Google Maps,
Yeah, or maybe like navigation system inside the car. It will give you, let's say, the most economical one or the most fastest one, which you usually take because you're always in a hurry.
is it that obvious?
And then it is also some blend of both, right? So, but still, it is giving you like a sense of all the environment, understanding the traffic, and giving you options so that you can take that, select amongst them, and then you need to drive, right? Now, coming to agents, here you can imagine agents like an autonomous driving car, right? For which we have given options of control of steering wheel, of the brakes, of accelerator, right? So now it can take action. It can sense the road, it can see the lanes. So now if we give an objective to keep on riding on the highway, it will sense if there is a car in front, what is the limit of that road through internet, and then autonomously drive and safely take you to the destination.
Kind of like what Tesla is doing for these.
Exactly. So this is what is the difference between like these agents and like other models that we have.
True. So I hope this maybe gave all of you a clear perspective on the difference basically between traditional ML co-pilots and agents. So Vivek, now let's jump to maybe real industrial applications. that we have also been delivering to our clients. So maybe one of the applications that we have done for a consumer electronics goods manufacturer recently. This is around their testing, planning, and reliability solution improvement. So normally in any consumer, any client basically who is in this sector, what they have is they have two primary goals, what they need to do. One is first they have to produce their products reliably. They cannot have any field defects, right? And they are actually producing, very highly usable products, like you have your water purifiers, you have your washing machines, you have your refrigerators. So these which are there in everyday usage. Another thing that you would want to do is, since you have to earn quite a lot of revenue, you would want to have a high production rate and therefore a very low turnaround time for actually producing these products. So normally what happens is they have this reliability testing lab setup, and in that what they do is for each and every product type that they have, they do a mass production or a first pass approval test planning. And there is basically a lot of supervisors who study a lot of data. It could be around their actual test execution environments. It could be around their historical test records. It could be their field defects rates. It could be the consumer reviews they are getting from the service centers, all of these kind of things. And then decide how to modify their future test planning.
Okay.
So it could be that, let's say, imagine a scenario for a water purifier. They stopped getting complaints altogether from the field, right? So what they could do is to cut the turnaround time and increase the productivity of the production of that water purifier. They would reduce certain tests in the test planning. That is how they will take an action. And let's say they observed a new type of defect in any other country when they sold it there. So in that case, they might want to take a call on creating a new kind of test plan.
Okay. So AI agents are now understanding these scenarios and then devising newer test plans as well.
Exactly. Okay. So this framework, what they have is the ERRC framework. And then whatever the humans were taking actions, we gave these goals to the AI agent. We set up those plumbing with their historical, all the data sources, their QC labs, their reliability labs, publicly available consumer reviews. All of these are being fed into the agents. They are actually now even being fed the future test plans, and they are now actually modifying those future test plans based on this framework.
Let me give you another example. This is around cement, right?
Mm-hmm.
So for one of the cement plants here in India, what we did was we had like a traditional machine learning model that was predicting the quality of the clinker that is created. So just to give you a brief, in cement plant, what we do is we have a kiln. It is like a furnace where we put in raw material, and then we put in coal and we put in air to burn that coal and then create clinker, and then we grind it up so that we can get cement, right? So when we create this clinker, which is the intermediate product, we need to have proper quality. So for that, we created like a model, traditional machine learning model, which was analyzing the quality parameters of the raw material, the process parameters during the clinkerization process inside the kiln, and then predicting what would be the the final quality parameter C3S, right? We had another co-pilot that was majorly understanding if there are any specific increase in the SEC, which is the specific energy consumption, if that has increased or not. It was analyzing multiple process parameters, giving out any issues, and then a probable and a possible recommendation as well that what should be done. Now what we did was we had an AI agent that came in, which read through this ML model, which read through all the results from the co-pilot and was also exposed to the optimization problem, so that it could then suggest actionable insights as well as take actions on the shop floor for main process parameters. So in this, there were like 7 actionable that usually like their operator used to take actions on. So now the AI agents uses these 3 different models, takes the results, and then directly improves the process so that it is always in the stable range, so that we improve the energy usage, like reduce the specific
the main goal basically, that's
exactly
improving the SEC.
Improving the SEC, improving the quality, as well as increasing the throughput. So all these together it was able to deliver and then take actions on the shop floor as well.
That is quite interesting, Vivek, actually. And one thing I realized, like once you were explaining, and even in the example I gave, is that even the AI agents that we are delivering now travels through that the same 3 steps we were discussing earlier.
Exactly.
Like first you need to have the traditional AI models, then you need to have those co-pilots, which will eventually then become the basis for your AI agents to study all that data and then take action.
Sure. Another example is like in power plants. We have soot blowers. So in power plants, what we do is we use coal, we burn it up so that we can convert that heat energy and use water to convert it into steam, and then from steam we generate power, right? Now, whenever we burn coal, it produces ash or soot specifically,
Right.
like technical terminology. So that soot gets it clogs the entire furnace.
Soot
Right.
basically has what? Maybe lower heat conductivity, can we say, than
Yeah.
metal?
Yeah,
Right.
so it reduces the heat exchange across different sections, right?
Right, all the pipes wherever that water
it-
and air might be traveling,
Yes,
so
yes.
heat exchange might be diminished.
Yes. So what we do is we have like one model that predicts like if there is a fouling that is happening, if there is laser deposit that is happening inside the furnace, and it keeps on calculating this fouling index. And then we have this AI agent that first understands for all these different sections inside the boiler which section has like a bad fouling index, and then automatically triggers which of these soot blowers we should trigger. Soot blowers are like we pass steam, flash steam, so that it can remove all that ash, and then it is collected at the bottom, right?
Right, okay.
So yeah, such kind of again closed loop functionality where we like control the entire DCS system is what can be done through AI agents.
Got it. So, Vivek, now maybe like we have delivered all these practical, basically solutions to the industry. So, one question that definitely comes to mind is what is powering all this up, right? There must be something really insane going on behind the scenes, which is actually able to, help us do this.
Yeah, like capture all these different varied use cases, right?
Right. So, this is one of our Paclon's like the main product which helps LLMs understand how the data is organized and understand what relations exist between this data. We call this unified data fabric. And what it is essentially is a combination of unified namespace and knowledge graphs. So what happens is, we talked earlier about that we need to have data indexed. So what we have done in our unified namespace is we did not index just data. We also index the tools that you mentioned, right? So we have now a repository where you have all this, in the space you have all these informations of what all tools are available, what all automation actions are available for you to take, and what all data can an LLM read. But this is not, the complete picture. Now the next thing that an agent needs is to understand what are the relations. Like, let's say it will have to draw a causal reasoning that the data, if there is a change in a particular KPI or a particular measure, then there will be a causal modeling between the KPI to the actual processing parameter. So then what we did is we actually taught our LLM certain skills. It could be around domain expertise, like maybe production improvement, throughput improvement. It could be around breakdown, like corrective actions that you have to take once a breakdown happens. And then the agent, what it does is, using our tool, it draws these correlations, draws these parallels, and connects all of these nodes together. And this essentially then becomes our unified data fabric. So now whenever we have in a solution, whenever we deploy any of these agents, in the case of that CEG sector or the power plant or cement, these agents are now traversing through all that information in our unified data fabric and are able to then take those.
So the moat is not the model, but actually it is how we structure and contextualize the data and save it in a format where we can seamlessly expose the LLM models to access this data and then finally take actions, right?
Definitely. Like the structuring, the organizing, that is the main thing that is needed, because the more prepared data set an LLM has, it can then very in a focused manner inject those insights. But now Vivek, like let's say we have this tool. We have powered up LLMs with all these automations that they can do in the shop floor. So it might be very obvious. Let's say if I were given the goal that I have to increase production, right? And I'm in a scenario, let's say, where I have, let's say in the cable manufacturing sector, and I have these extrusion machines. So here the measure of production is that you have to have the cable rolling at a very high line speed. So it will be very obvious for LLM to just take a call that to increase in production, increase the RPM of the capstan or the caterpillar, right?
Of course.
And then I could just go to, why not let's increase it to just 10,000 RPMs, right? But then the machine might not itself be designed for that capacity. So the question here is then, how do we make AI responsible for the actions it takes? Yeah.
So here the main objective is not to remove people, but to elevate them. And all these models have to be explainable by design, which is like they should not be black box, and it should be a causal model which actually helps even the people who are on the shop floor understand as to why any agent took a specific action. It should be very much clear, right? And then what we do is we make these agents in charge, so that all the repetitive, tedious work of just looking on a screen day in and day out and then analyzing if it was there was a spike or there was a dip. So all that tedious work can be then given to an agent who can do it much better, because it can analyze it at a very higher frequency as well as continuously as well. You cannot be attentive all the time, right?
And like in quite a lot of plants, I have seen this. Like people's daily time is going into just, let's say, some mishap happened, some accident happened, and then the maintenance guy or the production teams are actually figuring out, going into the data, making an Excel, and then just reporting it to their management, right? Like
Sure.
the most of the time is going into this. Instead of them actually trying to go and solve the root cause, they are more into about reporting. So
Exactly.
maybe this is a way we could elevate people actually.
Yeah, the other thing is what we should how do it responsibly is by making smaller agents with a very specific trained focus, which is, let's say, there are small agents, one only for, let's say, maintenance module, one only for, let's say, ticketing, one only for a specific task. So our agenda is to create or agents as a mind of a very sharp engineer.
Right. We have to not over contextualize it. We have to
Yes.
keep it focused.
Yeah, so otherwise they start hallucinating or they start taking very random decisions, right?
Yes.
The other thing that we should keep in mind is how do we keep all the guardrails in place. As you mentioned, like if, let's say, a machine does not have capability to run at 10,000 RPM, it is rated only for 1500, like the AI agent should know not to give answers or suggestions that are not in sync with the physical environment. It should be like vary of what exactly is there, of like all the capacities, rates of all these machines, and then make sure all the guardrails are set. So now the agenda of all these people would be to create these AI agents, let them run the show, and they converse with these AI agents to set up all these guardrails so that the system, and to also give them proper objectives so that the show keeps on running.
Right. And another angle, I guess, in responsible AI is also around data security.
Yes.
A lot of clients of ours, they do not want data going out of the plant system. And if we were to use these like openly available, of course paid, but these foundational models being provided, then it becomes a basically point of concern for them. So in that case, one of the solutions that we have is either doing private cloud deployments or even on-prem deployments, where we host different even open source models on their on-prem servers. So that way we could actually ensure basically responsibility from a cybersecurity point of view as well.
Exactly. So their data stays inside their plant ecosystem, and then we have models that are deployed on their servers or by bare metal servers or even their cloud systems, and then they access it and give results. And also we need to make sure if we are taking actions on the OT side, which is actually taking actions on machine, then we should also have all of these models follow all the rules that are there. For
constraints engine maybe should be there, that which like whenever an agent is taking a call, like after it decides to take a call, it should maybe verify against the constraints, like these are not the things I can do. So I guess that's a lot of talk about responsible AI. And now maybe a lot of us want to understand where is the future, right? Where are we going? So one of the interesting ideas that I was having, I guess you also share this vision, was that eventually we need to have the self-optimizing plants, right? We have like kind of similar to what China maybe currently has those lights out factories, the dark factories, where people do not have to actually go into the plants itself to run their operations. And I do not see this happening to be one giant leap. I think there will be a sequence of steps happening. Maybe first we start deploying agents that are specific into domain goals, and they start attending maybe the plant's daily stand-ups. The production agent might be attending the production planning stand-up. The maintenance agent might be attending the maintenance stand-up. The quality agent might be attending the quality team's different stand-ups. So all of these agents are there, which are just attending the meetings. They already have the data pipeline plumbing backup already set up. And then now they are from these processes understanding what is the domain knowledge of that particular plant setup that they can gain. And basis this, once they have gained this expertise, what we could imagine is a scenario where larger level goals are being done by agents interacting with each other.
So let's say there is a maintenance downtime.
Yeah.
So the maintenance agent will tell the production agent that, okay, you need to stop the production for some time, and then that agent talks to the resource planning agent so that it can allocate like proper resources for those maintenance activities and remove them from the production side, something like this, right?
Definitely. You could have your, let's say maybe at some point in time, the quality agent probably flags that your main CTQ parameter is now deviating way out of normal. Then there might be a process control agent. The quality agent would flag basically that your CTQ parameters are out of range. The process control agent then checks that when that batch is produced, what were the process parameters, and then it would give me for my next batch production that you have to keep these things in mind whenever you are actually running the new batch of production.
Sure. And this can be like they can also have agents like that also interact with the procurement team so that it can start creating tickets, or through
it could do maybe, yes, you could have your spares and inventory planning sorted that you have a breakdown, you need spares, you need to have maybe you need to check your vendor SLAs, who can you call to actually service that particular machine. So all of these then could be done by.
So what you mean to say is that again smaller agents talking to each other. Again, if you let's say want to install a new factory, then this can also again be used, so repurposed again to the newer factory, take all the learnings from one factory to another so that we can do it seamlessly.
Definitely. So it could be like you have your A team, so you set up your first plant, you had your people come and work through the processes, and then now you have the A team of agents who are actually running it. So now you can have the same people who did the all the laying out, the setting up, yes. So they would now start replicating it to the other geographies probably, and this makes even organizations leaner in the long run.
So again, with all of this, I guess humans' role is going to change, where we will be configuring these different AI agents, setting up the data fabric so that it is seamless with all of these LLM models to interact with, and set up all the guardrails.
Yes,
so that
is very important.
And then all these mundane tasks of looking on a screen and just like clicking or changing knobs, that will all be done by agents, right?
Yes. So this could be one of our main key takeaways probably. It is not that AI agents are coming and replacing humans. It is just that agents will be actually elevating how humans operate in the coming future.
So
okay, we have 3 things to take home slide. So I guess what we discussed, everyone, is why the hype around AI agents has come, and for that mainly the reason is that we have started organizing. Plant teams have become mature around how to organize their data. The reasoning capabilities of LLMs improved quite a lot, and the concept of MCPs has gained immense popularity, and it helps to scale AI agents and the capabilities they have. Another is what is an agent? So agents, although they might be being sold currently as traditional AI models, but it is, I guess, a 3-step ladder. You have your traditional AI models, you have your copilots, and you have your AI agents. These the first 2 eventually power up our agent actually. And lastly, as we said again, agents are not pushed to be replacing people. People are just going to be elevated to take up the more, you can say, higher level of thinking. I guess that would be it for our session, and maybe now we can pick up a few questions if there are any. So the first question we have is, can organizations benefit from AI even if their digital transformation is still incomplete? What do you think about this?
So I guess if they do not have the full digitization picture in place, like they should first start doing that. We can have like smaller models that are only interacting with one or the other data sources, and we can have traditional ML models to only have a very short purview of the data and then give out some intelligence. But then to like have the entire AI agentic piece in running the show, for that the first step would be doing the IT OT integration, which is capturing all the data from OT, from the lab systems, from the ERP systems, from the SAP systems, from even Excel sheets or even PDFs where like we have in manuals written
SOPs,
SOPs, and even let's say manuals where we have maintenance solution written. So all of these are like huge books, but no one reads them. So there will be agent that will be reading through them and giving you proper solutions. And yeah.
So maybe it could be that definitely we do need IT OT integration, and that is like one of the things that we also as a company, whenever we are partnering up with any client, we take them through this journey.
Sure.
But yeah, even without that being complete, I would not think that AI agents cannot be plugged in. There might be some domain specific solutions which are totally on your L4 or L5 layer, which does not need me to go into the OT itself. I could be giving AI agentic solutions for the even IT systems as well, right?
Exactly, yeah. So I believe the earlier example that you took for consumer electronics, that was
reliability lab. I think yes, right. It actually did not require me to connect into any OT systems.
Sure.
We set up our own data ingestion system. We set up our own data pipelines, and now we set up that on-prem server on which LLM is hosted. What are the biggest risks, operational, ethical, or cybersecurity when deploying autonomous AI agents in critical industrial processes? Okay, that is a very good question actually. So since it has been asked in 3 dimensions, let's answer in those 3 dimensions. In operation, the main risk that we see is that you have all these automation actions, you have all these tools that you give to AI agents, right? And you need to make sure that, and you also have to maintain maybe your machine's longevity. So you have to make sure that your agent operates within those guardrails. You have to set up those constraint engines. You have to get those design specifications even from your OEM for the machines, so that you can maybe you can ask the agent whenever it has to take any automation call to run it only at the 80% or 75% of design capacity. So main risk in operational is that we need to operate within the design specifications. We cannot have agent taking any random call just to meet the goal it has been given.
Exactly.
What do you think about ethical though? This is quite interesting.
So again, coming to the ethical side, it can be achieved by again properly setting up the guardrails so that it is not, let's say, doing any malicious activities. So
okay, it could be that AI agents maybe venture into the area of privacy probably,
which is like the cyber security is what you are talking about. Privacy would be, let's say, we keeping everything in the same servers or within the boundary of the system so that the data is not exposed outside,
right?
And the data is secure. So
one ethical challenge probably that I see is that maybe people might have an opinion that AI agents might be coming to replace humans. And this could be an ethical point of concern, that where are we going in the future? Do we not want to have our people earning? Do we not want to still create jobs? So for that, we have to basically understand that when we are setting up agents, we want to empower those people. We want to enable those people. We do not want to remove them.
Sure.
That is how our systems should be designed, that whatever agents are giving as outputs, they should be inferable to them. They should be able to reason out what actions are being taken, and then they should basically feel a sense of accomplishment when they are actually solving their goals while using agents.
Okay, we have quite a few more questions. How much human oversight is still needed when AI begins making operational recommendations?
So for this, we can have one specific agents which has all the guardrails, who can keep on analyzing if the other agent is properly working within the limits or not. But then humans will come in to converse with, or maybe write those prompts down, so that they understand the physical systems and then actually convert that into text or words for the LLM agent to understand,
But
or to organize the data in such a way so that it has all the information to take actions.
True, and I believe that is still a very lesser oversight than what we used to previously have. Because the things that have been solved is observing that data itself, where it is located, how to fetch that data, how to create those KPIs out of data, the analytics part, that is already solved. So the human oversight from the data pipelining to analytics, that can be totally removed. Then the second part is around generating those diagnostic or prescriptive recommendations. So how a human used to reason it out, that can also be now completely removed. The only thing that remains is for us to define clear-cut goals, clear-cut reasoning structures that an agent has to follow.
And I guess for that we already have so many engineers, like India, we are already
India
producing
is
so
the-
many engineers.
Yes,
I guess everyone should create that thinking capability and start taking complex roles instead of mundane tasks, is what I believe.
From this, I now remember, I guess, was it Mahatma Gandhi's line or something, that you, simple life and high thinking should be the way a human should live. But anyway, that is a digression.
Yeah. So I guess
Another question we have is what skills should manufacturing teams start developing now to work effectively alongside AI systems? Okay.
Skills maybe would be around having those processes set up. Maybe
start using AI. First thing is like start using whatever you like, which is AI, OpenAI or Claude. Get accustomed with how LLM models work,
how they reason it out,
how they reason it out,
understand.
and then only you'll be able to understand how we can leverage them to run your show. So,
And I'm also not a strong believer in actually, spending time to first maybe figure out ki kya padhe, what skills to develop. Rather than that, go out and experiment. There is a lot of sandboxes available that you can try, openly available. You do not even have to pay for such stuff. So maybe, yes, the best
start with
recommendation,
a simple
start using it.
Excel sheet, like upload it, get some data that you want to analyze done by that LLM model, give proper prompt, understand how prompt engineering works. So the major skill that I would say everyone should learn is how to interact with this model, understand their language, which is prompts, right?
Right.
So you can like have same like you can write same stuff in two different ways and then get very different output.
Right, exactly.
So yeah, interact with the LLM models, and every model is different. Like even if you, let's say, explore the older versions of OpenAI or the latest versions, same prompts work a bit differently.
Even
So
now,
it evolves. Yeah.
yes,
So
even
you
now
need
if I
to
am-
keep in touch with those models, understand how they like interact with you, and then
the main goal probably is that since the LLMs would be generating context out of all that backend context that they have, so we need to basically make it as deterministic as possible. We need to understand how to make the LLM always give the same response if I'm asking the same question.
Exactly. So there's one question: how can we talk about cost of implementation? Imagine a small organization with struggling with operational inefficiency, and they want to really use them in the system. How do you address this?
Okay, so for this, so I have a very recent example actually. So let's say you have a system in which we are not actually integrating with the OT systems, right? And you can completely set up your own data ingestion pipelines. So the cost can go as low as probably 10 to 15 lakhs, in which you could have your on-prem server, you could have a new data ingestion pipeline, and you could have agents solving for 2 or 3, very definitive goals. Or if you now wanted to have a full-fledged system in which you are maybe looking for a self-optimizing plant kind of thing, in that case, the cost definitely scales up, because then you have to invest in the hardware, you have to invest in the networking, you have to invest in the solution consultants.
So there is a quite a big range. It all depends on what is the what is the goal, and what data sources it has to create an impact on.
So the major cost centers would be hardware, where if you want to install it on premise, then you will have to buy servers, bigger GPUs, so bigger servers, because these local models are again big, so which have good reasoning, so they would need higher, let's say, RAM or GPU capabilities. If you are doing it on servers, again, like servers and GPUs are the major cost centers. Apart from that, how we install it, the consultants as you talk about.
And if you go for cloud solutions, the cost then gets reduced even further, because then you do not have to invest in the hardware itself.
Exactly. Pay as you go.
Yeah.
People are also saying to share contact details and email ID. Maybe Shubhangi can add it up in the chat.
We will share for sure, Shivaji ji. And any installation in EHS field on any company / any sector.
EHS field, is that environment, health and safety?
Maybe, yeah.
Okay, so we do have some implementations on this. We have we now actually also have deployed solutions where we interact with vision systems. So we have deployed quite a lot of solutions in which our clients already had their vision, the camera network setup, and we just had to tap into that network setup in NVR, and we were able to do solutions around people safety, right? Or even human-machine interaction, these kind of stuff, or even detecting fire probably. So we have seen these kind of implementations with quite a lot of clients.
For environmental thing, like we again earlier we were talking about power plants use case, right? So we have solutions around how we can have lower carbon, like decarbonization of the entire system, so that we can have lower CO2 emissions. So there are solutions around that as well. Like we can separately talk on the problem statements, Shivaji ji.
And then, okay, another question by Shivaji. Again, typical time for
cost
deployment and cost of agentic solutions. The deployment time, again, it can be as low as 1 or 2 months.
Yeah.
It all depends on the number of data streams, the number of physical systems or the processes we have to do.
But if the data is already structured, like we can start with a very smaller POC within like a time of a couple of weeks. That is also possible, yes.
So, okay, we still have a few questions. What business problem should a manufacturer solve before investing in AI, and what are the cybersecurity requirements?
The main business problem to solve probably would be around the data pipeline, right? Setting up those hardwares which can actually collect data from their existing machines, and then having it maybe centrally available via a UNS broker, right? So if that thing is set up, then AI is just layer very easy.
The data ready so that you can then start investing in AI.
Okay, we have. Can any installation, pharma industry sector or R&D laboratories? I guess Shivaji, we can directly share our contact and connect more, because we do have solutions for pharma and R&D labs as well. Like one of the labs, one of the solutions we mentioned in our this webinar was around the CEG sector reliability lab itself. Have we covered all the questions then now?
Okay, let's go to the top.
How can agentic AI improve real-time decision-making and procurement, where usual negotiation is required based on different market intelligence, considering different constraints in supply chain operations without introducing additional risk? Okay, that is again a very interesting question. Here, I think the major thing to understand is I guess the procurement thing, it works a lot on the network itself. How good is the relation with the vendor? Because the essence is that you would want to purchase anything at lower price, and you would want high serviceability into that.
So you can have agents that can go and explore for that specific item, like different vendors directly, and then also shoot them emails automatically, which are probable good vendors who have good ratings. They can automatically shoot them emails. Also talk to them regularly. If there was a reply, then also reply it automatically. If there was no reply, then remind them back again. and
One very
automate the
interesting
entire.
thing could be that you have a voice agent probably, which could call, and make it seem like you are a real person who is contacting a
Of
vendor,
course.
and then start collecting data from that vendor around how flexible that vendor is, and how easily serviceable they are.
Yeah, so we have
And then-
Aura for that, right?
Yes.
So we already
So
have a
Aura is the
product.
solution for that. And once you start making calls, your agent can then start collecting data. So this helps you solve the first contact problem. And then what you can also have is, once you are in this ecosystem where you have done a lot of such procurements across time, now your agents also have key in your various negotiations. How did that particular vendor respond? How did that particular vendor maintain their SLAs when they were actually, in the delivery or the implementation phase? And all of this then could help the agent take calls on whenever new such requirements could come.
Exactly. And also, if you have, I guess you already covered that, but if you have like a repository of historical, let's say, procurements, then it can also categorize each and every vendor, give them scores, which one is better, which one is
Definitely.
not, and then maybe for any newer, let's say, PO that has come up, in that case, automatically select, okay, to call directly to this vendor because it is reliable or faster
You
or
might have
cheaper.
a caller agent probably, and then you might have a systems builder agent. So basis the caller agent, and then you might have maybe overall goal tracker agent, and the goal tracker agent has to make sure that you get the best procurement, you get the best negotiations, and basis that it is either requesting the caller agent to keep on doing cold calls or calling their older vendors, and the builder agent is making these systems themselves. So for this also we would not have any human actually creating those models, the flexibility scores and stuff.
Sure.
Another agent is actually entering your Excels or even your existing any system to engineer those features.
Okay.
Okay, I guess that ends the question. And I hope all of you had a great time in our first and newly revamped Lunch and Learn series. And we will be coming back with quite a lot more such series. Thank you for your time.
Yeah, thanks, Siddharth. Thank you everyone for joining. Have a good day.